everyone.
Hi, everyone. Thanks for joining. I think Jason, thanks for asking. He saw that he hit this error, and then he asked me about it, and I thought it'd be a good opportunity to kind of share what I found and sort of tips on debugging tricky issues like this. So welcome everybody. Feel free to interrupt me at any time. I put together a few slides to help me mostly clarify the kind of flow that happened here. So if you want me to stop and explain something more, feel free to interrupt. Um, so some of you might have clicked merged at some point and then got this error. And this has been sort of happening in the last 1 or 2 weeks, I would say. I'm not sure why it has increased in the rate, but it has definitely become a problem. And yeah, it's a very obscure problem. So I'll kind of delve into the details on the issue there. But first, before I do that, I kind of have to step back and talk about what exactly happens when you click that merge button. So when you click that merge button on step one, that actually issues a post request to the Rails controller. That then triggers on step two an asynchronous job to actually come back and because you haven't actually all the pipelines haven't actually succeeded, there's a process by which we say, okay, we're going to schedule this job when it finishes, and then when it comes back, right before step three, let's say your CI pipeline just finished there, then we go and do some work, or we actually process the merge. So that's where the interesting part happens, right? When the merge worker on step three actually runs, we do a bunch of things. We first update the database saying, hey, we're gonna lock that merge request and we're gonna do something with it. And then it becomes sort of this back and forth with Gitly to actually make that merge happen. So you'll see in step 4 and 5 and 6, it's a bit of there's a bunch of round trips here where we tell Gitly, hey, I want to merge this branch. Gitly comes back and say, okay, here's the merge commit I've given you. I haven't actually done the merge yet, but I've given you the commit to kind of to 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 go and actually do the merge. But the first thing I need to do before I actually merge that is to check, can that user actually do what can actually merge that merge request. So you'll see in step 7, this is the pre-receive hook that happens when you push something to Git. Now Git won't accept anything until this pre-receive hook actually succeeds. So what happens is this process, which is now a Golang process called Gitly hooks, will then make an API call back to Rails, at which point it does some checks to say, hey, is this push okay? And if so, come back and say okay, and the merge goes through, right? So that's the happy path. That's what's supposed to happen, and usually that's what happens whenever you are successful. Now, when we saw this error, someone brought it up and I first looked at the logs and I kind of delved into the logs to see, is there any error message happening along this path that would be very clear about like what had happened, right? And so if you look at my note, I didn't see anything obvious. Essentially, I saw step 4 happen, but then I didn't see anything after step 7, the pre-receive hook. I just didn't have any visibility into that. So sometimes the logs can tell you the answer right away, right? You'll see the error message that says clearly you did something wrong, or there's a a rebase conflict or something that happened. But in this case, nothing. So you have to kind of take a different approach and kind of work backwards and kind of theorize what happened. So and the error message actually tells you a lot here, right? You are not allowed to push code to protected branches. Now, this is a very obscure message because there's so many messages that look like that, but are not quite like that. So if you look at the list down here, these are the bunch of error messages that we supply, right? So you can't delete protected branches, you can't merge code, you can't push code. Like there's a whole set of messages we say based on permission checks, but there's really only one message that matches this particular pattern. So that actually helps us a lot because we can narrow down the possible cause of this. Like I said, working kind of backwards. So, you look at this and we see that this push protected branch is this message. Okay, so when do we actually show this push protected branch message? So if you kind of look through the code, it's actually used in only one place. It's in this method called push protected branch rejected message. So this is basically a method that will
Sam,
display.
sorry to interrupt, but is it only me who sees the slide not
Oh,
switched yet?
sorry. I'm sorry. I am not sharing the right. Am I not
Yeah,
sharing the right screen here? Thanks for interrupting me. I'm
yeah,
actually.
no problem.
let me just go back to my other share. Sorry, thanks for interrupting me. I should have. Now, did you see this here?
Yep.
Oh, okay. Sorry, I was projecting the wrong slide the whole time. Um, so I'll go back and back up a little bit. You'll see that it's you're not allowed to push code, protected branch. It's in this one particular location here. Um, so you'll see that it's in one place. And if you work backwards, it points to this message here, this protected branch push check. So we do a bunch of different checks, and one of which is if you're pushing to you're pushing a branch, we end up in this code path. And right, you'll see that there's an if block here. The first block is, hey, is there a matching merge request? Well, what exactly does that mean, right? And the second one is like, okay, we actually fell into this category. In the second case, because that's the rejected message, right? So that's really interesting because that kind of narrows down the problem. So either the problem is in this first if block or in the second one, right? So which one is it? And if you look at, okay, well, what is this matching merge request actually doing? Well, it creates this class called matching merge request, which runs this match method here. And what does that match method do? Well, it does two things, right? It's basically looking for a merge request with two characteristics. The first one is this with state lock. So is this merge request locked? Now I mentioned, I mentioned in the slide 3 that we lock the database entry. And then the second thing it looks for is there a merge request that has this SHA in it, right? So this in progress merge commit SHA is that merge commit that Gdk created that said, hey, this is the thing I created. I actually haven't merged your branch to master yet, but this is the kind of the working merge commit, right? And so this is basically trying to find a merge request that's basically in progress, right? So that's really telling here because we're looking for very specific characteristics here to finding merge requests. And then you have to figure out, okay, well, what actually does this locking and what actually updates this SHA and, what can I do about that? So if you kind of dig through the code and you look at our merge service, you'll see that this is the block here that is doing this, right? And these two lines, this first two lines is where all that magic happens. The first thing is we have a in lock state, which essentially updates the database and says this thing is going to be locked. And then in this block, we do a bunch of things. Now this commit method is actually doing a lot of things. It's actually trying the merge. So you're basically getting the merge. The commit is basically saying, hey, I've actually merged this thing, now do everything else. So that's why you have this after merge business, right? So, but if you look at this this method commit, it actually calls the merge method in the repository, which does a bunch of other things. And in the line 853, it's actually telling Gitly to merge this thing now. It's saying, okay, I'm ready. I want you to merge that commit SHA that you gave me to this target branch, which in this case is master, right? And then in this block, it says, hey, this is the commit ID. This is the new commit. After you've merged the master, this is the new merge commit. I'm sorry, this is the new SHA that you should use. No, I'm sorry. This is the commit ID is actually that in progress merge commit, right? So you see in the 854, we're actually updating the state of the merge request here to indicate that, hey, this thing is in progress. After this block is finished, I'm actually going to do the merge, right? So this takes a little studying, right? Because it's doing a lot in this block here. So in this block, it doesn't actually merge anything until this block is finished. So until after 856, line 856 is run, nothing has actually happened. So this database update. So, but there's a lot of this. So once you do this, once you finish this block, we have to step back and say, okay, where in this flow diagram is this actually happening, right? So this is a bit confusing here, right? So you look at step 5 and step 6 here. And I'm kind of rewinding back and forth, right? So we did the update of that SHA here, and this yellow note here after step 5. And then after we've done that update, we then will say, okay, do that merge, right? So that then the Gdk call goes after step 6 to actually tell it to merge. Once Gdk has received that confirmation that I want to do the merge, it then does that pre-receive hook check, right? So the pre-receive hook runs and says, hey, can I really push this thing to this branch? And so that's where all that machinery happens, right? So this is kind of what I call the two-step merge dance, because we've got to do all the stuff in this red block. We've got to set it up so that the merge request is in a state which is 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 ready. And then in step 10, in this allowed check, we're actually trying to figure out, hey, do I have a merge request that matches these characteristics that I updated in this red block, right? And so this is where that problem is happening, because I know that if I didn't find a matching merge request with these characteristics, I'm going to fall into um, this second block here, and I'll talk more about why that's a problem. But basically, you'll see that this is kind of telling me that, okay, there is something wrong with the state of my merge request. I didn't find a merge request that I wanted. And so why is that? Well, one thing you have to be aware of is on GitLab.com, normally this would all happen no problem on your single database, but on GitLab.com, we've got read-only secondaries, right? So we do this because, you can't, it's hard to scale a system without having read replicas, because there's a lot of traffic and most of it is read. And so ideally, most of the traffic can go to these replicas, right? But what we don't have on these replicas is a synchronous commit, right? So if I make a change to the primary database, it doesn't get propagated to the secondaries at the same time. So and the reason it doesn't is that there's performance trade-offs with that, right? Like if you wanted a totally synchronous database system, you're sort of trading off that, that the performance, right? Because suddenly you've got to wait. If you've got 10 replicas and I make one change, I've got to wait for all 10 replicas to actually get that change before I do anything. So we have an eventually consistent system, which basically replicas will pick up the change as quickly as they can. It's not necessarily going to happen, and for the most part, it's going to happen pretty quickly. But there are times when it actually, you actually see replication lag, right? And if you look at this Grafana dashboard, most of the time it's 0, but then we get these ugly spikes from time to time, and this spike is showing it was a 2-minute delay. So I'm not sure what exactly happened, but sometimes we've got backups running, sometimes we've got a lot of traffic happening, and so replication lag starts to build up for a short amount of time, and as soon as things settle down, it catches up and goes back to normal. So immediately when I saw this problem, I was like, well, this probably has to do with replication lag, but how can I confirm that this is actually the problem? Well, as I said before, I mean, this is the way our protected branches are set up on this GitLab repository. We've got 2 different permissions, right? There are certain people who are allowed to merge, right, in the second column here, maintainers, and then there's people who are not allowed to push directly to master, right? And so this is where this block is really important, right? Because if I didn't find a matching merge request, then I go into this, hey, can this user push directly to this branch case? And then obviously not, because I don't want my I don't want anybody pushing directly. So we show this message, and this is the failure we got, right? Okay, so given this is a pretty solid theory of why this happened, how do we reproduce it? Well, first I should talk about, how does our load balancer, we've got this code in EE to handle database replication, and how do we deal with lag there? Well, there's two main ways that we do it. One of us is just like, let's avoid this problem entirely. I call this the avoidance strategy. You can do this by, if you enable transactions, this load balancing code will immediately just go to the primary, because in a transaction, you could be updating stuff, you can be doing all sorts of things, and you probably are doing a transaction because you want to write something in a consistent manner. So that's one way to do it. And incidentally, Sidekick right now doesn't use the load balancer. It always goes to the primary. And I think this was done because most of the time Sidekick is doing a lot of updates anyway. So, read replica doesn't come into play very often. And then I think Yorick did a lot of analysis and found it didn't really help that much to kind of offload to Replica at the time we were doing it. Now things have maybe changed since then, and I know Scalability has been talking about enabling load balancing on Sidekick. But anyway, that's an important point I'll come back into later. But the second strategy is to make the application aware of lag and make the application be able to handle this gracefully, right? So in Postgres, every time you do a write, the database will write to some log, and it's called this write ahead log, right? So that if the database crashes, it can restart and play back this log and come back to a consistent manner, right? So you can think of it as a pointer to every time you write, there's a new pointer to this log, right? So great, that's really useful here because if I make a write, I can track that position, right? And so what happens right now is when you make a write to the, if load balancing is enabled and you write to the database, the current connection will stick to the primary because you kind of want a consistent view, right? Because if let's say I updated my password or my profile and I do something later, I kind of want to see this consistent view of my user. I don't want to update something and then I hit a different replica and I see a completely different, I see the old value, right? So we have this sticking mechanism, right? And so you'll hear a little bit about unsticking. Well, what is that? Well, basically, it's a way of saying, hey, I've written to this this pointer, this wall, I have this wall position. I know where I actually committed my change. You can use a replica if the replica has seen that change, right? So that if that replica has picked up that pointer, then you're good. So you can unstick and kind of read from the replica. So that's a simple idea of sticking and unsticking, and Yorick has blogged a little bit about that in this 2017 post. Okay, so there's a trick in Postgres, and you can create a delayed replica. So what this means is that you can have a replica that's lagging from the primary by a constant amount of time. And you might want to do this because of disaster recovery, for example. Like, so say somebody drops your entire database and you don't want that change to be replicated right away. You really want like an hour or 2 hour delay to make sure that if something happens, you can recover from it. So this is why this feature is useful. And the way you do it is there's this recovery configuration file that Postgres provides, and most of this stuff is standard, is set up when you set up a replica. But then there's this extra setting you can add to it called the recovery min applied delay. And you can specify here how long you want the delay to be. And so I just chose 1 minute because it was a reasonable amount of time to kind of to reproduce the prompt. So, and when I did this, and you can read more about how to set it up in this issue. We should make it easier, but right now it's not that easy to set up in GDK. But when you do this, you'll have a replica and a primary, right? And so one trick I really enjoy with Postgres is to log every SQL statement coming through the database. Now Rails does log some of the stuff, but it won't tell you if you've got two databases. It won't tell you which database it went to, right? So, if you change the Postgres configuration to enable all log statement, you can do some cool things like, hey, I just want to see all the logs from the replica having to do with merge requests, and this is what this GDK tail command does. And so when I reproduce the prompt, which is basically I created a merge request, then I had a different user merge it. In the log message, I saw that the replica received this query, which is this. If we go back to the original slide of the finding of the matching merge request, right? So, it helps to kind of run this query on the Rails console to see exactly what it is. But you can tell by this in progress merge request commit SHA in the query and state ID. If you weren't sure if 4 is really locked, you can actually go to you can look through the code and you'll see that locked is indeed number 4. Right. So I've now I correlated the two things here where I'm pretty sure now the replica, even though it's 1 minute behind, is receiving this query, and this and then basically I saw the same error message, right? This, you are not allowed to push code to protected branches. Great. So let's go back. Well, how do we fix it? Well, as I said before, there's a couple ways. One way you could fix it is just say, hey, in this query, let's just use the primary all the time, right? And that's the first approach I took because, well, that's the most straightforward. But if you think about it, Um, this allowed check in step 8 happens all the time, right? It's if you look at GitLab.com, it's every time we push or we clone or anything, this thing is always checked. Now maybe pushing is less frequently. This whole checking of branches is less frequent, but it still could be potentially a big performance overhead if you direct everything to the primary, especially if you've got millions of repositories and everything has got to go through the primary. So, and when I was doing benchmarking, I was noticing this query for in step 10 could take, half a second or more. And so that started getting me worried because, well, that, that starts to add up to serious time. Um, so I kind of shied away from that. Tong brought up in the review, well, I'm a little worried about the performance implications. So how do we improve that? Well, we can go back to the whole sticking mechanism. Right now, the sticking mechanism does something like this, but it kind of, it makes some assumptions that everything happens within the same database session. So let's say I update my user profile. I expect, I expect to do more things with that user profile. So it will just stick in that current session, but it doesn't handle the case where I've got multiple things trying to read and write, right? So in this case, in this picture here, the Git hooks is doing this pre-receive check. Sidekick is doing database updates, and Rails is doing the database check. So it's again this query is happening over 2 different processes here, right? Sidekick and Rails. So we can kind of use a similar trick where, okay, I'm going to mark the location. So after step 5, so this is the point where I've updated the database. This is where I really want to know, is this replica caught up to this point, right? After step 5, if I've got all that data there, I can use a replica. So what we do here in step 6 is now we write the write ahead log location to Redis. And say, it's at, pointer X or pointer 5 or whatever. And then when after step 10, where we actually check if you have access to push this branch, we go and say, hey, what is this? If I'm using a replica right now, what is the wall location of this database connection? And if it comes back and says, yeah, you are at the right point, then we can use that replica. Otherwise, we're going to go to the primary in step 13, right? So once we're on the primary, this query actually goes to the right place. Now we've got a consistent view of things, and then, hey, we've got a matching merge request. Good, and the push now will go through. Any questions so far? I know I've said a lot.
I have a question, if you don't mind, Stan.
Sure.
So this pattern that you just described with using Redis to kind of keep track of the wall pointer to kind of know if you should use the replica you stick to right now or not, and instead go to the primary, that sounds like a pretty general concept to apply in other places where this problem might arise. Do you see that being the case? Like when you came up with this solution or this to address this bug, do you see any immediate places where this could be applied, or do you really think this is just a one-off?
Yeah, and that's a good question. And I think there's probably other cases where this is happening. We just don't know it, right? Because usually replication lags is so minimal that people either refresh or they don't think about it. In this case, it has to be totally consistent, otherwise you get this failure. So I do think this pattern, and I'll talk about that in this next slide in my conclusions, I do think this pattern is applicable to a lot of things, right? So we may need to generalize it, or we may need to find some sort of construct that says, hey, this thing actually has to be in a consistent manner before I do this, right? And so, that's the hard part, is what are the things that may fail if we do have a 1 minute delay in all our replicas, right? So that's kind of what I'll talk about in this conclusions, is that, as I mentioned, I think in my first attempt to fix this, I did this, but I didn't realize that step 6 wasn't actually happening because Sidekick doesn't use the load balancer, even though it's configured, right? So even though I had step 11 and 12 and 13 in place, step 6 wasn't happening, and so we were still getting the problem. So then I said, okay, this follow-up merge request, even what I'll do now is I'll do this, you know, even if I don't have a replica, I still have a wall pointer, right? So even if you have a single database, you know, there's still a log, right? So it still makes sense for me to write this thing if I have load balancing configured. In other words, if there's, you know, settings in my system that says, hey, I'm using load balancing, right? So what I wanted to avoid is like not if people weren't using load balancing, I didn't want to have to update to Redis just in case that was causing, you know, excessive traffic or whatnot. So, but you know, generally this, you know, points to eventually consistent systems are tricky, right? We sort of traded off. We made this trade-off of having an eventually consistent system for good reason, but you do have to think about consistency problems. And you know, we have a mechanism that sticks to the primary that generally has worked well for us. You know, we had similar problems early when we introduced load balancing for like CI runners, right? It's like, for example, when you update it, when you have a new job, you want the runner to process it. And we had similar things where we had to modify the API to stick to the primary. But that really only happened within the same database session generally. So we haven't had, I don't think to my knowledge, something like this where we had sessions that cross different processes. And so, you know, to your point, Jason, I think we have these in our systems and we can uncover them by using a delayed replica and see what fails, right? Like if we run our test suite, maybe through, we might be able to catch some things that we didn't expect. This fix that I put in, I think is very narrow. It's looking specifically for these matching merge requests, but you can imagine like, hey, I've updated my protected branch settings, same problem happens, right? And so, you know, that happens less frequently because if I update my protected branch settings and it doesn't take effect for, you know, 10 seconds, people probably don't notice, right? But in this case, it did matter because just all this stuff has to happen in lockstep, otherwise your merge fails. Any other questions?
Yeah, I have a couple of questions then, if
Sure.
possible. So why, in your opinion, it started to happen like only through this time window? So is it related to some particular load patterns or
It's a
something
good question.
changed in the...
You know, in the past, there's been changes in the systems that, for example, like a year ago, we started seeing more replication lag for some reason. And it turns out we had enabled SSL compression by default. And that's different from SSL. SSL compression actually tries to like actually compress data. So what that change is basically more CPU load because the database nodes were spending more time, you know, compressing and before they were sending over the data, and so the replicas were having a harder time keeping up with all that. So that's one example of a change that happened a year ago. Now, what's happening now? I'm not sure. It could be just, you know, we've got more load, right? We've got more database users on the system. It could be, you know, our snapshot strategy. It could be some other performance regression. Yeah, so
Yeah,
that's a good question. I don't know the answer to that right now. And so,
okay, thanks. And do we log how often do we fall back to the master, or is it too
not yet. And
expensive
that's
to
the
log
next
at this
step. Yeah,
point?
that's next step. I've been
Okay,
meaning to do it, but I would like to get data from that, and it's because it'd be good to know
great.
like how often this is actually happening. I just wanted to fix the problem first before, but yeah, you're right. Logging is going to be important.
Okay, cool. Thanks, Dan.
Hey, Sam. Do you think that perhaps more like a solution for the future would actually be to take the lock out of the database and move it perhaps to Redis instead? I think that's the main, like, the actual issue. Like we're using the database and the database can handle it.
Well, there's two things, right? The lock and also this merge commit SHA, right? That's we're looking for merge requests that match those two characteristics. Well, moving to Redis, what does that mean? I mean, Redis is still, you know, Redis only right now we're just using one primary too, right? Like we're not using delay. We don't have any replication delay in Redis because we're not using Redis for reads, I believe. We're not using the secondaries. The secondaries are just hot standbys, I believe. You can configure Redis to read from the secondaries, but I don't think we're doing that at the moment. So I think we're kind of pushing the problem off, right? Like that's just saying, hey, can we just use a totally consistent database? So I don't know if that necessarily solves a problem, because you might have scalability issues too, where now if pushed all this data into Redis, now can I handle that load, right? So it's possible Redis can do that. That might be a kind of a solution, but if this problem is happening generally in our database, we're going to have, the answer isn't always going to be push into Redis, right?
Yeah, before we start sharding everything.
Right. So when you say sharding, you mean sharding the database, sharding Redis, or?
I don't know what will be the solution, but it doesn't look like this will handle like 10 times more loads than we have today.
Yeah, perhaps not. I think there's a lot of ongoing discussions about how we, I think the sharding working group kind of stopped because it was such a complex problem. And I think we're looking more at how do we run multiple large instances of GitLab. So if we've got marquee customers, they'll have a different instance entirely that, doesn't suffer from, a lot of the millions of open source projects that might be using GitLab.com. So, but yeah, that's one form of sharding. It's kind of a bigger bite than just sharding by project, but sharding by customer organizations or companies.
I have another question that is
Sure.
sort of related, but comes from a different perspective. So being from the security team, my first thought when you mentioned that the API call to check for allowance of the actual merge comes after we've gone through the work of preparing the commit, finding out what commit SHA is going to be used and stuff like that, right? I didn't know that was the case because I'm usually not that deep in the inner workings of the backend, but that's super interesting. And do you think this could be abused? Like, for example, to trigger the preparation of many merge requests to force the application to go all the way until the pre-receive hook, only to get a disallowed or a not authorized at the end?
So I think you're saying is, can you do denial service by just pushing lots of code? Is that what I'm hearing?
The merge requests, right? So if you attempt to perform the many merge requests only for this pre-receive hook to get a denied, you sort of multiply your computation requirements on the backend, but in the end it all fails.
Right. I mean, that's no different from just pushing. I mean, this pre-receive hook happens whenever you push code. So whether you're merging or pushing code, right? So you could potentially deny any service by just trying to, do a lot of pushes. Well, usually these pre-receive hooks and these allow checks are pretty fast and not terribly expensive. But yeah, I mean, anything for large repositories, definitely we've seen like this allow check take a long time because we've got all these push pre-receive checks. For example, we've got like file name checks, we've got file size, we've got all these checks that are actually really expensive if you got large repositories, and we have seen that being problematic. So, even without like malicious users, we've actually seen just regular users have trouble dealing with this, and they might time out. Like if this allow check in step 9 doesn't happen, it doesn't finish in 60 seconds, it fails. The push fails completely. Right, so we have like I think that's actually a bigger problem right now, is that we have stuff that isn't performant for large repositories, let alone like just somebody trying to abuse it with lots of pushes or lots of big pushes.
And that goes a bit to my second question, and what Gabriel was mentioning, like trying to find an initial step to solve it. Is there a reason why you personally think we aren't finding out if the merge is going to be allowed in the end, finding that out early on, and then shipping that this was validated, please do it when you're done and are able, whatever process carries it out in the end? That would probably help with both the performance problem by not doing the whole round trip and then finding out it's not not authorized, but also it already has been validated. So perhaps the pre-receive hook isn't even needed because Gitly, is it Gitly? Yeah, Gitly would know I can merge this because it was validated by Rails at some point, and that information was cascaded to me.
So you're saying kind of moves to step, the actually that allowed check a much earlier in the process. Is that what you're saying here?
Mm-hmm. Do you think that makes sense under some, like for example, in this case, would that be?
Well, that's a good question. But I think the problem is we've also got to handle just regular, the way we handle every push right now is to use this pre-receive hook, right? So it's kind of fundamental to our system right now. And so every push that you go, so, merge request is kind of a one case where you actually push code, but you can just let's talk about the general case where, the average user is pushing code. How do you do a permission check there, right? And I think the answer is still, I think you have to use a pre-received hook. I don't see any other way of handling that. I don't know if
because so the push goes directly to Gitly, or
yeah, it does go to Gitly, and then Gitly will receive the input, right? So in order to know what you're actually going to be allowed to do, you need to know like what's actually being pushed, right? You need to know that, hey, this user is pushing the master or this 10 other branches, right? And so I think the only place you get that information is actually in the pre-receive hook. And so even if you solve it for merge requests where you short circuit that or somehow, you still have to handle the more general case where, users are pushing code.
Thank you, Stan.
But it's a good question. I know that Gitly does do things like without even asking for permission. Like Gitly just creates that merge commit or creates temporary branches without like asking for permission. So it is a good question. But I think we're kind of stuck in this world. Great. Any other questions?
If I may, I had a last one.
Sure.
You talked about benchmarking for this particular one, and you mentioned that you were a bit worried about the matching merge request step. Was it?
Yeah.
Yeah. Can you show that very quickly, like how you got worried about it, like how you did benchmarking, if it was different to?
Yeah, I mean, I essentially took this query here, the select one statement here, and I think I literally just took this query and just put it into our database explain analyze, and the first time I ran it, I got it took 500 milliseconds, right? And it's faster the next time because things gets paged in and all that. But the fact that the first time I tried it, it took 500 milliseconds, that started to worry me because if it just takes a microsecond or a millisecond, probably not a big deal. 100 milliseconds, I start to get worried, and then 500, it's like, well, that's serious time, right? And granted, pushes, like I said, pushes don't happen as much as read clones, right? So when most people will clone or down a pull. But you still don't want to get in a situation where you might bring down GitLab.com because suddenly you put a hotspot on the primary, right?
Thank you, Stan.
Great. Any other questions? Thanks for all the great questions so far.
Yeah, I just want to go back to a previous one. It took me a while to actually look again at the diagram and realize that if we actually execute let's call it like execute the checks as part of let's say sidekick job worker, like to try to bypass the pre-receive hook for this specific case of the merge request, maybe we can get things a little bit better, because then you still have like the connection coming from Rails, not from Gitly, and I think you can at least for this case reduce the problem.
Yeah, it might be a local optimization. That's my worry because, like I
Yeah.
said, you do have to worry about the general push case, right?
Yeah,
So
it doesn't solve the general push case, but maybe for this case it can help.
yeah, it's something we should consider. I mean, we might need to think about how we do this because, I think gradually over time we've added more and more to this allowed check, right? It used to be a really simple thing, protected branches or not. Now it's got like 10 different things we check, and I'm not sure that scales.
Stan, a quick question related to this one. So when the push occurs, as opposed to the merge request, which starts from Rails, starts by the client within Rails and then goes on, where does a push directly from the Git command land in this workflow? Like,
yeah, it's a good question. So I have a different diagram somewhere else, but if you imagine that, from step one is the push, and then basically it will eventually end up in step 8 right away. Like it will go through workhorse and then Gitaly, and then eventually it will get to the pre-receive hook. So you can probably just ignore steps 2 through 7 if for a regular push, but it will eventually end up in step 8. Does that answer your question?
yeah, that answers the question. And also why you initially mentioned right away, oh, we're missing lots of information if it's a normal push, because it skips those 3 steps in the beginning. Thank you for that. Yeah.
Great. Well, thanks everyone for joining. I hope you enjoyed it. I hope it was clear.
Thanks, everyone. Thanks, Stan.
Have a great weekend.
Yeah, you too.
Bye.